All right, so about 4 months ago, I bought a generator, Honda generator. I found it on Craigslist. I paid $1,800 for it. It runs about, I think, $4,000 for a new one. Um, and I wanted it because, in case obviously we had a power outage, we had one last year, and we were out without power for about a week, and you don't realize how much you are dependent on power until it goes out, and then you're realizing, oh shoot, our stuff in our refrigerator is going bad, or we don't have any water. You don't really think about that. We have a well, and you don't think about the electricity that it takes to pump that water up. So we didn't have our water ran out. Basically everything came to a stop. So trying to be more self-sufficient, we got a generator, and I made a shed for it outside, and I'll show you that in a little bit. And now I'm in the process of running power up here to the circuit breaker in the house, and we're going to hook up a sub panel that's made specifically for generators, so that when your power goes out, you take the sub panel and you flip the breaker to the generator side, and it feeds these circuits automatically. Select circuits that you want for powering up certain things in your house that you feel are important. Once you do that, it's pretty it's good to go. So the panel that I have is we're going to end up putting it right here. So here's the external sub panel that I'm going to use for the generator. It's a Protran. I don't know if there's a model number on here or not. Oh yeah, model number 31406C by Protran. It has a 220 circuit here, which we're going to hook up for the well pump, and the other breakers will be refrigerator, water heater. Basically, we want to divide the load into spread the wattage out onto this side and equal wattage on this side. And I think I don't remember, this is 30 amp maximum. I think this is 8,000 watts total. Anyway, we'll have like the refrigerator, water heater, breaker for the lights, certain lights in the house, and what's the other one? I don't remember what we're going to do the other one. I think maybe the microwave, so that because our oven currently is electric, so at least if we power the microwave, we'll have something to heat our food with. So anyway, this will end up mounting into the wall here. They have this conduit that's supplied that'll go through, come through here and up through there, and then these wires come in and go to the individual circuits. So that's the plan, and we'll see how that works out. All right, so what we have here is the Protrans, which is actually the brand is I guess it's called Reliance. Says Reliance and on the unit it says ProTrans. So I'm not sure when you're searching for this if you need to find it, if it's going to say Reliance or it's going to say ProTrans. Reliance is probably the company and ProTrans is the brand, is my guess. Anyway, so I also bought this, which is a separate item. This is because I wanted this to be mounted inside the wall and not all of this sticking outside the wall. I want to mount it in the wall, so I bought this this bracket that mounts into the wall. You can see along here, it's got screws that you put into the studs that are in the wall, and then your drywall sits back behind these tabs here, and then there's a face plate that goes over top of it, a trim plate that makes it look all nice and neat and deliberate. So this mounts into the wall, and then this unit here mounts inside of it, and it gets screwed in to the back here, and it makes it a nice little clean install. So these are this is the plug that I'll put inside the generator shed, and then this is a, a short cord that'll basically plug into the generator and plug into that plug, and then the conduit will run out of here and go to my circuit, my sub panel that I'm putting in. So before I even begin, I've already found my first obstacle. So my panel is 7.5 inches wide. So I need a 7.5 inch wide space inside my wall. So there's studs obviously inside this wall here, and I'm not sure where they're at, but this is my favorite. One of my favorite stud finders is a magnet that tells me where the screws are at in the wall, and when it stops swinging like this, it tells me that there's a screw right there. Now, to make sure that that's not just some random screw, I go down the wall, and there it found another one. So there's another screw. So that tells me that that is probably where my stud is at, the center line of my stud. So if I make a mark here between those two marks, I can see right here, this drywall and this drywall, there's a seam line here. So I don't need to go up above here, so I'm not going to mess with that drywall. So I'm going to end up cutting from here down. So I've made a mark of where my stud is, but I need 7.5 inches in there. And it's that's to the center. So if I go over 3/4 of an inch, because the stud's 1.5 inch thick, it puts me into here. So I have, and if I go way over here to the right, which who knows, because the window is over here, there's some additional studs, but then that means my electrical box has to run even further. So actually, let me see what the distance is for that. All right, so the weird thing is this: our particular house used to be a barn, I guess. So this electrical panel is right here, smack into the middle of our living room wall, as opposed to being behind the front door. We don't have a garage, so it's not out in the garage. So it's a weird place. So that's one reason why I want this to look as neat as possible. I wish that there was a cover that actually covered this instead of just a trim ring, but anyway, it is what it is. So my dilemma here is if I take this and run it over into this bay, will I be able to get up inside the breaker panel? So if I'm over here, back into here, it takes me over there, but I got all of these conduits coming up in here, and this is still hot. All these wires in here, so you gotta be careful poking around. I see a set of wires coming up here. I'm not sure where that goes to. What's weird is it doesn't have I don't know if there's any conduit going up into that. We may be able to use that one right there. And there's no more knockouts. There's no more knockouts on this side. So I guess I'm gonna have to open the wall up and see if I can use that one and reroute these wires in through a different way. But it looks like if I do go over to here, that all my wires, once they do come over and across, is long enough to get up in there. So anyway, we'll cut out this drywall and see what we have going on in here. Alright, that's what we're looking at. Got some nice insulation in here. There's some wires going through. Oh shit, bunch more. Well, that makes sense because the breaker panel's here. Of course, you would think that they would go up and over on a lot of these. They got 1, 2, 3 wires there, 2 wires there. See what's going on over here. Huh. So I was right, there's no this Romex coming up through here. That's what they just put in. Obviously when you wiggle that and this moves, that's what's feeding this one plug that feeds the light that's outside this wall here. That's good. I can, if I can get it in there, run the conduit up into that bay and rewire that. So I'm going to open this up a little bit and get it prepped for. What's nice is back behind these 2x4s, it's like a 2x6 wall, but they furred this out. A lot of insulation. Back behind here is more installation that was probably the original barn, and then they added these studs here to frame the inside and put more insulation. But back behind here, I can reach through, so I'm not going to have to drill holes through these studs for the conduit. I can run it back behind and then come through and get it into there. So let me get this opened up and cleaned up and see what we got. All right, so a few minutes later, I've opened this this little cavity out. I took a little bit of insulation out so I could put the panel in. I've done a little bit of blocking, and I can take my shroud here, put that into place. I'll screw that in onto the sides, and then we'll fish the metal flex through here, back behind the studs, and then over into the circuit panel. I thought I'd show you a little bit of what I found. So here's the wall again. So I took this switch that was in here, and I looked at it, and if you look back, down buried deep inside the wall was this wiring knot. You should never have a bunch of wires
come together with wire nuts on them, just buried in the wall. Anytime you have a bunch of wires like this, it should be in a junction box, whether it's an accessible, and it has to be accessible so that you can get to it. And I believe the reason for that is if these wiggle loose, or sometimes over a period of time, because the electricity pulses, these and especially if they're not tight, they'll end up loosening up. And if you don't know that this wire is buried in the wall, you won't have any idea to check this or to be able to fix it if you don't know about it. I don't have a whole lot of options, and this here's what I was going with, and my metal conduit looks like will just reach this. Problem is I need a 3/4 inch knockout, and this is a 1/2 inch knockout, and I have a 1/2 inch knockout that I can create, and I cut this hole here in the back of this panel. I think this is a 2 inch knockout, but I don't have a 3/4 inch knockout. And then the reason I had to do that is because my wiring that comes from the generator is going to come up through the back of my new sub panel, and I needed to get through this. So anyway, so I cut a hole in that for my wiring to go through. And then I also had to notch this 2x4 out down here at the bottom because, well, I might as well show you. So there's the bottom that comes down a little bit further, and when that sets back into the wall, it's not going to clear that. And then on the back side is my conduit that'll bring the power in from the generator, and that's what will end up going through that knockout hole. So my dilemma is I gotta go buy a 3/4 inch knockout hole. I don't see any other. Well, there is one on the side here. I don't see any other options, so I'll let you know what I come up with. This is why I cut out that 2x4. The thing is, I didn't really need to put this 2x4 this close to the box. I could have put it down here, and then that would have given me still this. I needed this vertical one right here, so that's why I put this here. But this should have been lower, so that this distance was a little bit higher, and I wouldn't have to do any of this. That would have been the smart thing to do. Hopefully my hole lines up. Hitting. Oh. This conduit does not want to make that sharp of a turn down. You can see it wants to go straight back. Oh, shit. And I don't have enough room to go straight back. It needs to do an elbow and go down. I don't know if I have one. So I went out into my storage area and I looked in my electrical box, and sure enough, I had one 3/4 inch 90-degree elbow. So all I gotta do is take this and swap it out for that. It'll go down like that, and it'll be perfect. right. So what you're seeing here is something that I have never seen anyone do before. And someone had taken flex twist connectors and used them to crimp the Romex to the breaker panel. This is an absolute no-no. So I had to go through and pull all of these out, disconnect the wires, and swap these out with the proper crimp fasteners. Unbelievable. Oh, that's not the one I want to use. That's for metal, small metal conduit. So here's the generator shed that I made. I made it so that it was fully accessible so I could pull the generator out to do some maintenance on it. So, but, well, it's not quite done yet, but there's the top, lifts up so I can reach in here and do what I want, and then also the side comes off like that. To the side gives me full access in here to do what I need to do. Made a little concrete pad for it. So here's what we got going on the outside. So here's my generator shed. I have another vent to put in that side. That's why it's not done. But you can see there's a vent there on that side. And so I got to run power basically from back behind there in that corner, behind the propane tanks, along here, and then along the side of the house, over to here, and up and into the wall, and that's where the circuit panel breaker panels are. Okay, so here we are. I run all the wires up through, and there was some consideration that needed to be done on how to hook these up. So I've jumped way ahead and have pretty much, well, I do have everything done because some time has passed since you saw me running these wires up. So basically, we had to go through and relabel all our breakers, go through the entire house, find out which breakers controlled what plugs, which ones were on the refrigerator, because how they were labeled before was very vague. So now that everything is properly labeled, we made sure to figure out what our priorities were. Our main concern was trying to find what we wanted to power up during a power outage. And some of the things that were important to us was making sure that our well pump was working. Our well pump is 220 volts, which I didn't realize that until we had a power outage and I tried to hook up our well pump to 110 volts and it didn't work. So our well, making sure that we had water during a power outage, make sure that our refrigerator could run off of the generator, some miscellaneous lights so that we could see. We have a gas stove. We got rid of our electric one so we don't have to worry about cooking. And our water heater. Water heater kind of is an issue. I wish I would have gotten a larger breaker panel here because I only have 5 circuits on this panel. The 2 center ones here are for the well pump. When you click those on, the well pump will run. And then B and E over here are for the water heater. So a water heater, we had to hook up 2 circuits on that because it's 220 volts and 4,500 watts. Our generator is 4,500 watts.
The water heater has two heating elements, an upper one and a lower one, and I assume if the total is 4,500 watts, that puts each heating element at about 2,200 watts each. So I believe I can just flip breaker B and use one heating element in the water heater. It'll take longer to heat up, but I believe it'll still work. I haven't tried that yet, but I think the theory is there. And the other breakers were for just the power for some lights so that we could see. I think that's basically it for what we ended up wiring up. So in wiring up your new breaker panel, it comes with 5 sets of wires, black and red for each set. They're all labeled A through F. The first thing you want to do is find out which breakers that you want to run off your generator. And we've already gone through that and figured that all out, and we wrote it down on a piece of paper. So let's just say, for example, well, this is a good example here, breaker number 12. Let's say this one was our refrigerator. So what you do is you disconnect the existing wire that's going to the breaker. You wire that wire up to the black wire, let's say to A. So your A coming from the new breaker panel goes to the wire that you've taken off your existing breaker, and you tie wrap or you wire nut that on there. And then you find the A wire that is the red wire, and you connect that to your breaker that's now bare, that you've taken the wire off of. So basically you take your wire off of your breaker panel, you connect it to the black wire, you take the red number A and you connect it to that breaker that you've taken it off of. And what that does is when you flip your breaker panel here on your new panel to the center position, it turns everything off. And then when you flip it up, over here it says generator, and all of a sudden then you're running off of your generator power. It's pretty much as simple as that. And you just do that through all your circuits. You know, like I said, once you figured everything out, and wire nut everything up, make sure everything's tight. Try to be as neat as possible. And you gotta watch the load that you have on here. What's nice about this breaker panel here is it has a little gauge on here that shows you how much wattage that you're using, so that you can make sure that you don't overload the generator. Since we've installed this, we've had power out twice, and we used it, and it's worked great. It's been a lifesaver. It's well, maybe not necessarily a lifesaver, but it certainly makes things a lot more easier during a power outage. And when the power goes out, we're not worried about losing stuff that's in our freezer and not being able to see, even though we're semi-prepared with battery, lanterns, and so forth. So it works pretty good. Highly recommend it if you're out living remotely. Don't completely rely on having power all the time, and having your generator and this panel certainly makes things much easier. I think that's it. Anyway, thanks for watching, and see you in the next video.